Hello everyone, I'm Dmitry Gerasimov, CEO of Cellframe Network, and here I'm with
Ian, and I'm the CEO of Quantum EVM.
And we are here just after talking 2049 conference where we were participating, not without stand, but just networking, visiting, a lot of impressions. And let me start from my own impression of this conference. First of all, we met a lot of L1 protocols, but they was not looks like quantum safe, and that was difference between this conference and coin and consensus in Hong Kong, that here was less talks about quantum threads. However, they were, but maybe you can talk about this more than me.
Yeah, so everybody I talked to is actually aware of the quantum threat, and it wasn't news to anybody. The news is that nobody really understands it still, and they don't know what they need to do. But everybody understands that quantum is a threat to Bitcoin and a threat to Ethereum. Nobody I talked to was like, oh yeah, the public key turns into the private key using physics. Nobody said anything like that. Some people were talking about the hash and other stuff. There wasn't any layer 1 protocols that were quantum safe in anybody that I met. I met with Algorand, who says that they're going to have an official announcement, and I'm looking forward to it. I met with Hedera, and they said they're going to try to fix something within their either their marketing or their technology. I don't know which. And I met with Diamante, who just said, go away. They claim to be quantum safe, but they use ED25519. And so they're just relying on the ignorance of people not checking their code. And they tried showing me this code. Look, we have quantum safety on alpha. It was just a speed test. It didn't actually do anything. It was just 150 lines of speed test. And they had me read their source code on the beach on a phone, and I'm like, this isn't a blockchain. This is a speed test. So
incredible! You participated in so many events. Unfortunately, I was after Moscow Blockchain Conference and tried a lot, so almost have not visited any side event, but visited the main one. By the way, it's an interesting situation when people became aware about quantum threat, but they still not so confident about how to protect against it. Ever startups, ever service projects, why so?
I think that the main reason that they don't understand is that they don't understand the threat itself, and that's just comes down to education. There's a lot of misinformation inside the Bitcoin group about the quantum computers being used to do proof of work, which, yes, they will be able to do that. It won't be good probably for like 5 or 10 years after you can take the Bitcoin with quantum computers. So it's going to be far easier for the quantum computers to, number one, take the old Satoshi's coins. Number two, they'll be able to break the protocol and just steal all the coins in transit, and 0 Bitcoin transactions will be safe. And then like years after that, they'll be able to do the hashing. And they're just so focused on the hashing as if that's the only threat. And that they've released so much misinformation into their community that we have to like have a larger audience and a larger voice just to talk about what the actual math says. So I think that compared to like 6 months ago, much more people are aware of what's going on. It's just that the messaging is still confused among the Bitcoin crowd. The messaging is still confused among a lot of the service providers. There's a lot of people still releasing ZK, even though ZK is completely broken.
Unfortunately. With ZK, I'm still wondering about post-quantum ZK. We are moving forward in this direction. However, all the world only have first variants of aggregating signatures. They are not ring signatures, so we can't build for now any ZK based on this. But I think it's a good direction. But we still have no post-quantum ring signature with ZK ring signature. That's the problem, unfortunately. And by the way, so if it's not just broken, but as I understand, classical ZK ring signature after QD also will broke its anonymity.
Yes, so any secrets that are protected by ZK will be revealed when the elliptic curve or the discrete log of the ZK is revealed, meaning all of that protected data is no longer protected. There's other weaknesses in ZK. Right now, you can prove a false statement, and you just construct against some variants of ZK snarks, you construct a false message and you send it to the prover, and the prover says, oh, it's true, because there's like an inverse of the hash. So you're doing a trick to convince the prover. And that was actually published by Ethereum Foundation, and then they're still like, yeah, go ahead, ZK guys.
Oh, by the way, her anonymity will work for hacker, for stealer. He will produce a false message, but without disclosure of his person, with disclosure of his address.
And it's also going to be possible for them to forge new ZK using your identity on some ZK protocols. There is ZK Starks, like the construction of the Stark and the security of the Stark is hash-based. So it's safe, but the way that everybody uses it is in conjunction with a snark, and the snark is not safe. And if you're half safe, you're completely broken in most cryptography. There's very few variants where you can do a hybrid cryptography where both have to be broken before it can be attacked. And that is very, very, very dangerous still.
Yeah, I hope there will be soon some variant of a Chipmunk signature. By the way, when Chipmunk signature appears, Chipmunk signature is the first post-quantum aggregated signature that can put a lot of signatures together into the one. It is about 30 or 100 kilobytes size, I don't remember. 100 kilobytes size is a huge size of signature, but it can compress up to 30,000 of signatures. So for post-quantum signature, it's really good ratio. No, it can be usable for Cellframe network. However, why it's so important, because for current moment we use variant. We have consensus based on a tons cat chain, but ordinal cat chain has to collect all the signature from all the verificator in the round. Because of huge post-quantum signature, we have to delegate this process. So technically, we have right now DPOS, not the POS itself. We have delegated, but this delegation happens every round. It happens with a pseudo-random function that selects the verificator for every round, and it's an attack vector, unfortunately. And to exclude this attack vector, we strongly need to implement Chipmunk signatures that we are working on. Our team is working on this implementation. Unfortunately, original version of the Chipmunk signature is written on Rust, because we have a C project. Yes, we'll implement Rust for native smart contracts. About non-native, we'll talk about a little later. I keep it in mind. However, we still haven't finished the Rust, and for my opinion, better to implement it in C. Why? Because it's about 40% of CPU's consumption is in for hash calculation, and about 20% of CPU usage is for signature verification. So it should be as perfect as could be. Better ever to write it on assembly, for my opinion, but here we'll have security issues, you know. And we will see we have such issues. However, it's a rare situation when we face holes in signature algorithms. Sometimes it happens, I know, but I rely here on AI tools a lot. At least we still haven't hacked. By the way, if somebody looks our video and found some bug, please contact with me. We always have a bounty program. It's always open. Okay.
So the aggregation is really important. If you look at Lightning and you look at Solana, they compress all of the transactions into a single signature. Doesn't matter if they throw in 10,000 or if they throw in 500 transactions. It becomes this one signature, and they check it for the same cost as if they were to check any one of the transactions. As long as all of the signatures are valid, then that final signature is approved. Chipmunk does not scale to this infinite level that you can just put it all into one. In Chipmunk, it's more expensive to add signatures, and the signatures are more expensive to check. But when you can aggregate the signatures, then you can have a much better performing network without having to trust a whole bunch of computers to do work for you.
Yes, and we will not have to delegate the verificator. We don't need to select only few verificators for signature for every round. Right now we select about 10 or so. Yeah. Okay. Also, we just talked about smart contracts, and your project is focused about bringing Ethereum compatible smart contracts in the Cellframe network, or for us, for Cellframe network, for us, for all the world, just to be quantum safe. Can you tell a little more about how will look the movement of the existing smart contracts to your platform when it will be ready?
We're hoping to have testnet, in a week or two. We have a developer testnet right now, and the transactions are executing in some situations and not others, and it's just getting all of the pieces tied together in the correct way. It's just a few bugs away, and I've said that for the past couple of weeks, but I think we're just really a few bugs away from having a public testnet. Once it's released, all you have to do is download, our quantum safe Web3 wallet, and add our quantum safe Web3 libraries to your web page by adding a Q in front of the name, and then your dApp should be able to talk to our chain, and your customer should be able to talk to our chain. The actual deployment should just be recompile and push. We're doing a lot of work trying to make this as seamless as possible, so that developers and people who are running a DEX or something don't have to redo anything in their contract.
That's most important. The less things to redo, the lower level of entrance.
I want it to be like 15 minutes total, including adding the Q libraries to the web page.
Yeah, it should be. By the way, you mentioned the wallet, so that looks like will be the first wallet from third party in our ecosystem. How close it to the public tests? Also, you will publish it with testnet as well, or later?
It's required for testnet. The full Web3 wallet to do signatures on that come from, like, let's say a DEX, that you're trading against a DEX on a web page, and they have their beautiful GUI, and it'll compose a transaction that goes into the quantum safe Web3 wallet in the browser, and then that browser will sign the transaction and submit it to the network. After it's submitted to the network, then everyone's able to process. This is a different kind of execution than what Cellframe has used in the past. And you guys have actually made some huge advancements in the way that you're handling, wallet transactions and the dashboard.
The dashboard now is obsolete. It goes to be replaced with a new coming Cellframe wallet that's already in it's already in beta test. It's available for download. Dashboard, it was ambitious idea to make a wallet with a full functional blockchain node available for common folks, for ordinary people. However, unfortunately, we failed with this because of sync issues that that get the user experience not so good for. By the way, in 90 or 95% it works well. Just you need to wait some time for synchronization. Yes, you are in this 5% that was not that got a lot of problems with it, and not only you. By the way, a lot of my partners, a lot of my friends faced this trouble. Said me, I cannot ever use it. I don't see balance. How can you use it? So we are now focused on the Cellframe wallet. I can advise anyone who is newbie in our ecosystem, don't download dashboard. Try with a web wallet, with a, well, not web, with Cellframe wallet. It's really, it's in a beta test. It's ready for common usage, just for transactions, for breaches, I remember. By the way, the beta is soon. I believe it will be complete in about a week or two. It's close to be released. By the way, about your wallet, it will work only with QEVM or for all the ecosystem?
So we use a different transaction protocol for talking to the Web3 layer versus the base layer. So even though that there is a QEVM running on Cellframe, the QEVM port talks the Ethereum protocol, and then the base layer talks the Cellframe protocol, and that's two ports on the same machine. And we're starting off with just the Ethereum version of the protocol because we're debugging it and we're trying to just get it launched, and we're hoping that by mainnet we will support the Cellframe base layer on QEVM, as well as being able to send transactions to other networks like the Cellframe backbone, like NodeSys, and be able to communicate these things. And we also want those CF20s that are all inside the Cellframe network to be all the way pushed up to the EVM layer for DEX purposes. But that is also going to be delayed slightly. And I don't like the delays. I want everything now. But we have to pick what we do first.
Oh, nobody likes delays. However, it's a financial tool, so better to delay than get some troubles with someone's money. By the way, also we have something to deliver to make your life easier. We're preparing as I told before, we're preparing the new type of token. It's CF02. This is a new Cellframe standard token standards for custom smart contract implementation. It will be a smart contract driving token that could be connected with someone else's virtual machine or any code processor. Doesn't matter, and I believe it will help you before the mainnet to have a better integration. I know on current stage the Cellframe node, it's really complicated to integrate so deeply, especially with the smart contracts, because we have only one kind of token in production.
It will help us, especially for sharding, because inside of a virtual machine is all of those memory and registers. And if we want to make them travel across the Cellframe network to other shards or other networks, then it's better to have a portability. It's possible to do it without, but it's a really bad mess because you're just referring to something that you can't see or interact with. Making them citizens of the Cellframe network is an amazing enhancement to performance and an amazing enhancement to the user experience.
I have my own big ambition to implement native CF20 addresses inside EVM. Yes, you told me before that it's almost impossible. But when somebody says that it's something impossible, for me it's challenge.
The problem is that you're going to have to write your own Ethereum virtual machine compiler. Not one version, but about 50 versions. And each one of them has 8 different storage methods for how the address is stored. And you're going to have to edit everybody else's horrible code.
I think I don't need to support. I don't think it's not necessary to support all these versions, because here you have ports from anyway they need to recompile. Usually this compatibility we need when we have some old code that we don't touch at all. But if we have a port on the new quantum ecosystem, I think it's okay to ask their developers to modify a little the ancient code to make it work on the last version of compiler. So I think it will be enough to support just the last one.
Well, I'm supporting old contracts, and I want to make it just as easy for the developer as possible. So we're doing that extra work to make it on the VM side. But all of the tools, they struggle. We're going to make some of that work done for you by being able to support the Cellframe base layer and the Cellframe addresses inside of the wallet. It's able to talk to the web page and all of the JavaScript. So we'll get some of that done for you, but there's a few really painful touch points that we're going to delay for you to enjoy, and that, like the compiler.
I think we can really on the stage forget about the old versions. It will be enough just to release. We can call it MVP or some kind of this. If we'll have the request of such kind of guys, please support 0.1.1 version of Solidity. Please do something. If we'll collect a lot of such requests, yes, it will be. It will have a sense to support it. But I think nobody will ask it. Most of developers develop with the latest version of compiler.
And I need to support the entire ecosystem to be able, for everyone to be able to port to our network instead. And so we want to provide as much compatibility as we possibly can.
I think we need to ask community, by the way, about this. So if you are a Solidity developer and look in this video, please write in comments what the version of compiler you use for your project, and is it okay for you to have support only for the latest version, or you need to support some legacy or so?
Instead of me tackling the address space at the, going over 256 bits, we're going to try to support other things. We're aiming at either providing Solana support or SUI support. Please let us know if you want either Solana or SUI. And we were thinking about providing support for the RISC-V architecture, RISC-V.
About SUI. SUI, it's a WASM-based, right?
SUI is WASM-based, but it uses the move language, which is a subset of Rust. And so it's WASM with a ton of helper functions. And in order to go from WASM to WASM, you have to recompile and you have to do a bunch of extra effort. It's the API stack and the citizens that matter more there. The reason that we chose Ethereum Virtual Machine first is because we have like over 300 chains that we can support, and we can provide broad support, and everybody can use the same virtual machine. And we have a larger audience that we can help move to quantum safety. But if you do Cosmos WASM, then you're stuck on Cosm WASM. And then if you do the near VM, you're stuck with only supporting the near VM, even though both are WASM based.
So you have a wider support of different WASM dialects?
The raw WASM includes all the machine instructions for each byte and how long each variable is.
Okay.
The helper functions are written separately by everybody.
Okay, we need some native smart contracts, and we selected SU as you advised. but we ever haven't started any development. So if you over with EVM quicker than you think, it should be a miracle. But if it happens, I think maybe you can help us with this as well.
It's a possibility. It's a possibility.
Anyway, if you will stuck with, if your current work will hold you more than you have predicted, we'll do WASM SEO integration by ourselves. Don't worry. But also we are more focused on to develop more conditional transaction blocks to, our idea to replace most of smart contract possibilities with conditional transactions. But here I think they should be combined together. Why? Imagine you wrote smart contracts that during execution using these conditional transactions. Because conditional transactions, all their logic is written on C, it will be cheaper, we will have a cheaper gas. So what do you think about to integrate these things in EVM for Solidity developers?
So it would be nice if you didn't have to have like contracts calling contracts, and you could just use a conditional to deal with two separate contracts as needed and put that onto the hand of the wallet and the user, instead of having to require developers to build these very specific use cases. My main concern is that I want the network to be as fast as possible for performing transactions, and the more logic that we put on each transaction, it's a burden to every transaction, not just the transactions that use it. So I want that to be very modular, and I want it to be very fast. There is a use case for optimizing for speed. Solana made the use case strong. It's just you also have to have uptime, and they don't have that part yet. So I like the idea, but I realize it's a trade-off. And whenever there's that trade-off, I'm like, we have to have the speed first, and then we can do the logic. If we can do the logic without impacting speed, yes. But I think that the future of Web3 is going to be more business-oriented. And when the business wants to run certain conditions, or the business wants to run like escrow, they should be able to do that by a conditional transaction without having to hire Solidity developers or hire Rust developers. They should just be able to say, okay, we're going to use escrow for this transaction and not need any development. It should just be a button.
To escrow, we have already this logic to escrow, yes, and it's really business oriented, as all the functionality in conditional transaction. Okay, and the last thing I think we should to discuss today is it's the most common question from people when they heard about quantum threat and that we are working with a post-quantum project. How long have we to wait till the Q day? When it happens?
When will those public keys get turned into the private keys using physics? We don't have any clear data. There's a fog that surrounds this answer, and there's layers to the fog. One of them is that the companies that make the machines are incredibly optimistic about themselves, but pessimistic about the industry. That makes you wonder, is everyone lying? And I don't think so, but more importantly, I think that the risk begins, or very clearly, when they say they're going to break it. And when they're talking 2027, that's when we should begin the risk calculation. And I was involved in some discussions about when is Q day, during Token 2049. And the point that we were making back and forth is, well, what if the NSA decides that they want to break Chinese encryption to defeat missiles? Well, then that means that PsiQuantum would be the #1 candidate, and then the #2 candidate would be some of these defense contractors.
They use quantum encryption, not post-quantum. One photon transition of K.
So PsiQuantum has a quantum computer, and then if the #1 leader for quantum encryption, you're correct. Post-quantum cryptography is what we're doing, and quantum cryptography is the leader is SK Telecom in South Korea, and it's using encryption by physics, and you cannot break the encryption without breaking the physics in some way, maybe by sniffing the sensors.
Oh, there are other techniques like sensor overloading, but that's all about physics. By the way, it's an interesting moment where physics cross with financial and appears a lot of myths and lie about this.
So the question was, well, would they actually announce it? And we think that they would keep it quiet, but they also wouldn't be breaking Web3 and Bitcoin because it would expose the fact that they would be able to break the Chinese missile codes. And I mean Air Force missile codes, not nuclear missile codes. Nuclear missile codes are not plugged into anything. You just press the button, and it's a physical button, not a button on a website. But the friend or foe missile identification for Air Force versus Air Force, which plane do I hunt down? Well, that's just encryption that determines friend or foe, and it will only hunt the foe. So whoever breaks the encryption by having a quantum computer first, their planes are immune to the enemy missiles. And that's a huge asymmetric advantage in warfare that is mostly dominated by drones and air superiority. And if the drones are using old encryption and they're not using, Cellframe or post-quantum cryptography to manage that drone swarm, well, then they can just turn the drones around and have them aim at the ground.
And drone war, as I understand, most of problem is how to say it,
So there's lots of ways of shooting down drones?
I'm talking about jamming hardware that jams down the
broadcast strength,
and most of modern drones produce it to work independently when they have disconnected, or they work through the fiber optics.
Using lasers is another...
Lasers is another variant, yes.
Yeah. Where they communicate by laser.
So there are a lot of workarounds. So you see this, if you have such a quantum computer that can break somewhere secrets, better to keep this also in the big secret.
Big secret.
Big secret.
So if there is kind of a surprise in 2026, we would expect them to keep it a secret because it's way more of an advantage than anyone would be able to prepare for. And by keeping it a secret, they won't be breaking Bitcoin as a result, and they won't be breaking Ethereum as a result.
By the way, I think we'll face a lot of conspiracy theory when some people will lose their funds. By the way, it happens right now when some people lose their funds. They start to think, oh, maybe it was a quantum hacker.
Every time an old wallet touches their money and moves it to an exchange, like, it has to be quantum computers. They're here. They've been doing it all along. It's the NSA, whatever. The problem is that we don't know, and we can't actually tell when even after the attack, we won't be able to tell which one was quantum and which one wasn't. Most people agree that Q-Day is going to probably involve Satoshi's coins when it's known. But people could be hacking Web3, changing real-world assets and moving a whole bunch of DEX or bridge assets around, and we just wouldn't know it. We're just like, well, what's the chance that was quantum attackers? Very, very low at this point because the commercial level hardware is still pretty low. But by 2028, we're going to have so many companies that are going to be able to target Bitcoin that I expect that even if the first 2 or 3 attackers are completely owned by government agencies trying to keep everything secret, by 2028, there will be too many companies that have crossed that threshold. and will be able to break Web3 and elliptic curves at 256 bits.
So that's a very specific threat. We cannot know when it happens, but we need to prepare it before it could happen, before it ever could happen.
If you migrate during an attack, you're handing the attacker all of the coins in the migration, or most of them, or way too many of them. So the migration has to occur before the attack is possible. Otherwise, you've just funded some company.
It's like a virus disease. You need to be vaccinated before, not after. Everyone who looks like this video, remember this. Use Cellframe network or QEVM for smart contracts to keep your funds and keep your contracts safer. Okay, I think it's enough for today. Thank you for all your attention. See you next time. Goodbye.
Thank you.